You are at the hospital. You and your wife just had a baby. You both have brown eyes, but your baby has deep blue eyes, nothing like yours. Immediately, your mind goes to your neighbor Dick. He has blue eyes, and you've always been a little suspicious about him. But just relax for a moment. I will explain why two brown-eyed people can make a blue-eyed baby. To understand this, we have to go back in time. Way back, to a time when all humans had brown eyes. For most of human history, every eye on Earth was some shade of brown. Brown is the default. Your eye color comes from a pigment called melanin. The more melanin packed into the iris, the darker your eyes appear. Brown eyes are loaded with it. Blue eyes have almost none. Here's the part that surprises people. Blue eyes are not really blue. There is no blue pigment in your eyes at all. Instead, blue eyes work the same way the sky does. Light enters the iris, scatters off the collagen fibers inside it, and only the shorter blue wavelengths bounce back to your eye. It is an optical trick, not a paint color. Your baby does not have blue eyes. The baby has eyes built in a way that makes blue light bounce back. So how does a trait like this even appear? In 2008, a team of researchers led by Hans Eiberg at the University of Copenhagen studied the DNA of people with blue eyes from across Europe. They were looking for the genetic switch responsible for turning brown eyes into blue ones. What they found was remarkable. Every single blue-eyed person they tested shared the exact same tiny mutation. Not a similar mutation, the same one. Down to the same letter of DNA, in the same spot, in the same gene. That gene is called OCA2. It plays a central role in how much melanin your body produces. The mutation Eiberg's team found does not break the gene. It does not destroy it. Instead, it sits in a nearby region called HERC2, acting like a dimmer switch. Think of OCA2 as a faucet that controls how much brown pigment flows into your iris. The mutation does not remove the faucet. It just turns the handle almost all the way down. A tiny bit of pigment still trickles through, but it is so little that instead of brown, you get the optical scattering effect, blue. Here is where it gets stranger. Because this mutation happened only once, in only one person, at some point between 6,000 and 10,000 years ago, somewhere near the Black Sea region. Every blue-eyed person alive today, all of them, descends from that single individual. You read that correctly. If you have blue eyes, somewhere in your family tree, tens of thousands of generations back, there is one person, one ancestor, one single genetic accident that traveled forward through time and ended up in your face. But here is a question worth sitting with for a moment. Why did this mutation survive at all? A mutation that reduces pigment in the eyes should, in theory, be neutral. It does not obviously help or hurt survival on its own, and yet it spread. Researchers studying ancient DNA, including work published by groups analyzing Mesolithic European remains, have found that some of the earliest blue-eyed humans had dark skin and dark hair, paired with strikingly light eyes. The mutation arrived in eye color long before it showed up anywhere else. One leading idea connects this to something called sexual selection. A novel trait, something rare and visually striking, may have simply stood out enough that people carrying it were more likely to find mates. Generation after generation, the trait spread, not because it made anyone stronger or faster, but because it made them noticeable. There's something almost uncomfortable about that. A trait millions of people carry today, a trait some cultures have built entire ideas of beauty and identity around, have started as nothing more than a random copying error that happened to catch someone's eye, quite literally, thousands of years ago. Now think back to the hospital room. You and your wife both have brown eyes, but brown eyes come in different versions. Some people carry one copy of that ancient OCA2 dimmer mutation and one copy of the normal version. Their eyes still look brown because one working copy of the gene is usually enough to keep pigment production high. These people are called carriers. They walk around their whole lives with brown eyes, never knowing they are silently holding onto a piece of that ancient mutation. This is where Gregor Mendel comes into the picture. In the 1860s, working with pea plants in a monastery garden, Mendel discovered that traits can hide for a generation and then reappear. He called the hidden version recessive and the dominant version, well, dominant. Brown eye color tends to behave like the dominant version. Blue tends to behave like the recessive one. If both parents happen to be carriers, each one holding a single hidden copy of that ancient mutation, there is a real chance their child inherits two copies. One copy from mom, one copy from dad, two dimmer switches, both turned down low. Suddenly there is a baby with almost no pigment reaching the iris. A blue-eyed baby, born to two brown-eyed parents. That means if both parents are BB carriers, there is a 1 in 4 chance, 25%, that any given child will have blue eyes, even though both parents have brown eyes. So now you know your wife didn't cheat on you. You are finally relieved and can look your son in the eyes because you both simply carry that hidden blue-eyed gene without ever knowing it. By the way, this is Dick.